Multiplying rational expressions is going to work a lot like simplifying rational expressions. You want to factor everything that you can factor first and then see what you might be able to cancel from the numerator to the denominator. So this first example, if you notice there are no plus or minus signs within the multiplication problem here, which means there's no factoring to do. So what you might want to do is do some cross-reducing. If you notice the 15 and the 5, you could divide those both by 5 and get those numbers a little bit smaller. 15 divided by 5 is 3. 5 divided by 5 is 1. And now we can just treat this like a regular fraction multiplication problem. When you multiply fractions, you do multiply straight across. You don't need to worry about a common denominator. So first we'll multiply the coefficients, the 2 times the 3, and we'll get 6. Now multiply the x's. Well, all we have is the x to the 6th and nothing over here to multiply it with, so that will stay as x to the 6th. And then y times y to the 4th. When you multiply the same base, you add your exponents, so we end up with y to the 5th. Alright, in the denominator, you have a 1 times a y times an x cubed, so that's just x cubed times y. Now when we simplify this, we're just going to go left to right. First you have a 6, nothing to divide it with, so that stays as a 6. Now you have your x to the 6th over x cubed. X to the 6th over x cubed, when you are dividing the same base, you subtract your exponents, so 6 minus 3 is 3, x to the 3rd power. And then we can simplify our y's by keeping your base of y and subtracting those exponents. 5 minus, this is y to the 1st power, will be to the 4th. And then you look to see if you have any negative exponents. You go ahead and move those. Since we don't have any, that one is done. Alright, this next example does have some plus or minus signs in here, which means hopefully we'll be able to factor this a little bit. The first fraction, we're going to just rewrite the whole problem in factored form, and then we'll look to see how it reduces. So our first fraction, that's going to stay as a 3 over, now 2a plus 6, you can take out a GCF of 2, and you're left with x plus 3, times, now this is not a fraction, your a squared plus 4a plus 3. We can go ahead and put it over 1 and make it a fraction. And now if we factor it, because it's a trinomial, we're looking for factors of 3 that add up to 4. And that will be a 3 and a 1. So x plus 3, x plus 1, all over 1. And so we're going to look for anything that we can reduce. Similar to where we reduce the 15 and the 5, you can do cross-reducing like that. Basically, if it's anything from the top that will cancel with anything from the bottom across the whole thing. So you've got an x plus 3 down here, and you have an x plus 3 up here. Those will cancel each other out. Then you look to see if you have anything else that might cancel, and in this case we do not. So what do we have left in our answer? You have a 3 on the top times your x plus 1 over, on the bottom you have a 2 times a 1 or just a 2. When we first learned this in class, we left our answers like that, but let's go ahead, because we'll be working toward simplifying this further, and so do any multiplication that you can do. This 3, we can go ahead and distribute throughout here. So we are going to end up with a 3x plus 3 all over 2. And that will be our final answer on that one. Alright, this next example, again, factor everything you can factor before you start simplifying. So the numerator, you have a 6n squared plus 18n. You can factor a 6n out of both of those. We get n plus 3, so that was your GCF factoring. The denominator, we've got a trinomial, so factors of 8 that add up to 9, and that's just a 1 and an 8, so n plus 1, n plus 8, times, now this next fraction, you have that n squared minus 1. That's your difference of squares. So what did you square to get each term? We're going to work with an n and a 1. So we have n plus 1, n minus 1, all over. And then in your denominator, we have 2 times, factor out of 2, times n plus 3. Alright, so do we have anything that we can reduce or cancel with? I have an n plus 3 right here that could cancel with that n plus 3. We also have an n plus 1 that can cancel out. And then the only other thing, sometimes we don't see it till we rewrite the problem, but you have the 6 and the 2. Here's a 6 and here's a 2 that we can reduce those. If you divide those both by 2, you get a 1, divide this by 2 and you get a 3. So if we write out what we have left, in the numerator we have a 3 and an n minus 1 over n plus 8. And then final answer, we'll go ahead and multiply this out. You can distribute the 3n and we'll get a 3n squared minus 3n over, and the n plus 8, nothing we can do down there, so that will just stay as an n plus 8. Looks a little sloppy. Just n plus 8. And that one's done. Alright, last example. This video is getting kind of long, but there are 4 examples, so hopefully that'll help someone out. So this problem looks a little bit different, only because you've got x's and y's. So the way that we're going to work with this is we're going to do GCF factoring. So factor everything. You have a 3x squared y in that first numerator, so one term, nothing you can factor out, so that stays as a 3x squared y. Over, now in the denominator, our GCF, we have a 5 and an x squared that we can take out of both terms. And then that leaves us with an x plus 2y. Alright, so our first fraction is factored. Now our second one, we can factor a 2 out of both terms. That's our GCF, and we're left with an x plus 2y. Alright, in our denominator, our GCF will be 6 x squared y. And that leaves us with an x plus y when that one is done factored. Alright, so from here we're going to look to see if we can find anything that we can reduce. Now this x plus 2y and the x plus 2y, those we see right away. From here it's going to be a little bit nitpicky to see what we can cancel. The first thing that I see is you have an x squared and an x squared. So we can go ahead and cancel the x squared with the x squared. Again, because things are being separated by multiplication, we're allowed to cancel those separately. I also see you have a y in the numerator right here with this y down there, so we can cancel those. And then the last thing I think we can do is reduce the 2 with the 6. So if you divide by 2, you get 1. Divide by 2, you get 3. And then let's see what we have left. In the numerator, the only thing I see is this 3 right there. So we're going to have 3 over. Now in the denominator, we have a 5. 5 times 3. You can see here's a 5. We'll multiply it with that 3. So, something else we'll be able to do. Alright, we'll catch it in a second. 5 times 3 is 15. And then we have an x squared and an x plus y. Alright, so you guys may have caught, before I started writing the final answer, this 3 actually can cancel with that 3. If you missed it like I did, well, now I have a 3 over a 15 and I can reduce from here. So I can divide by 3 and get 1, divide by 3 and get 5. And let me move this over a little bit. So it leaves us with a 1 in the numerator. Now it's a 5x squared x plus y. And then let's go ahead and distribute that 5x squared into those parentheses, and we'll get 5x cubed plus 5x squared y. And now that one is done.